Hello all, welcome back to my YouTube channel all about VLSI. In this particular session, we are going to start with RISC-V processor design. But before going to start with actual processor design, we need to know some fundamentals that first we are going to cover. Then we are going to start with RISC-V processor design using Verilog. Now, before that, let's try to understand this particular fundamental things, right? Now, the first thing we need to understand is what do you mean by an instruction? Basically, an instruction is a binary command given to the processor telling it what operation should be performed, and uh, every program ultimately becomes a sequence of instructions. For example, if I'm going to have this kind of program which is written in some assembly language, then this is nothing but x1 is equal to x2 plus x3. So this is nothing but an instruction, and this particular instruction will be converted into binary format and will be given to my processor. So processor can basically able to understand the binary format instruction. So whatever you're going to write down in your assembly language, that will be converted into binary format by the assembler or the compiler, and that will be given to your processor. So basically instruction is like a command which you're going to tell the processor what to do and what it should be performing. Now, so what does an instruction contain? So basically, what is that instruction is going to have? So basically, instruction is going to have, generally instructions are going to have this kind of fields. First one is opcode, second one is source register, and the third one is destination register, immediate, function bits, and address offset. Basically, opcode will tell you what exact operation you need to perform. Like you need to perform addition, or you need to perform subtraction, or multiplication, or division, or shifting, or what kind of operation you are intended to perform. So your opcode is going to tell. And where is the opcode that will be present? It will be present inside your instruction itself. We are going to discuss when we are going to discuss about RISC-V. We are going to see what is this opcode, where exactly it will be present inside your instruction and all. And followed by source register and destination register, like why are they used and how they are being used, and what do you mean by address and what do you mean by function bits, like that we are going to discuss in great detail. So just this is just to give you a brief idea of how the things are going to look. So example instruction which I wanted to discuss here is simple instruction add x1, x2, x3, which is nothing but x1 is equal to x2 plus x3, where add is nothing but my opcode and x2 is nothing but my source register, x3 is another source register, and x3 is my destination register. That means I need to perform the content which is present inside my x1 and x2, and the resultant will be stored inside my x3. So this is the resultant will be stored inside your x3 register. So this is how your instruction is going to look like, and this is how your instructions are going to have this particular fields. So this is how your processor, this is how your assembler or compiler is going to convert whatever the instructions that will be present into binary format. And this is how this is nothing but a 32-bit instruction. So it depends upon the kind of architecture you're working with, what should be the instruction size of that particular architecture and all, right? Now, and this was about your instruction, like what do you mean by instruction and what are the fields which are present inside your instruction, and what you're going to do with your instruction and all, right? Now, we need to understand few more things like a processor, how it is going to deal with those kind of instructions which are being converted into binary format. So the very first step is fetching. So basically, the processor is going to fetch the instruction from the memory. So there will be some kind of memories which are dedicated to store this particular instructions, like which are known as instruction memory, IM, and data memory, DM, depending upon the type of architecture you're going to use, whether you can have a separate memory or whether you can have a same memory for storing your instructions and data. That will be decided, right? That we are going to see. And let's say if I'm going to have a separate dedicated memory for storing whatever the instructions which my assembler has converted into my IM memory, which is nothing but my instruction memory. Assembler is going to convert it, and that those particular instructions will be stored inside your instruction memory, right? Now, in this particular instruction memory, all the particular instructions will be stored. Now, what is processor going to do? The processor is going to fetch these instructions one by one. So the instruction is stored inside the instruction memory, and the processor uses a special register which is known as program counter. We are going to have a particular special register which is known as program counter, and it is going to fetch one by one instructions from this instruction memory, and it is going to read those particular instructions. The processor is going to fetch these particular instructions, and this is the step number one. Now, in step number two, we are going to have something, and this is one of the example. Suppose a particular memory is going to contain at address 0 this particular instruction and address 4 this particular instruction. Let's say if I'm going to have, right? Now, let's say if my program counter is equal to 00, then the processor fetches add x1, x2, x3. After fetching, program counter will be incremented like this. So this is how I can think of storing an instructions and fetching the instruction from the instruction memory, right? Now, the next step here after fetching is decoding. Like after fetching the particular instructions, my processor need to decode what exactly that particular instruction is going to say. So the processor tries to understand like what operation should I perform, and the instruction bits are divided into different fields like add x1, x2, x3, which is nothing but x1 is equal to x2 plus x3, which we know already. But the processor needs to understand, the processor need to decode it, right? So what it is going to do, it is going to understand what is the opcode. It is going to understand what is the source register, what is the destination register, and different kind of fields which we have discussed it previously, right? It is going to analyze what are those particular fields and what is the meaning of that particular field, what is the value which is present at that particular field. This particular stage, which is nothing but decode, is going to deal, right? And after decoding, it is going to come to know that okay, what it should do. So that is what it is going to do. It is going to execute whatever the things it has decoded. It is going to execute whatever the instructions which the user has given, and this is how a processor is going to perform a particular architecture or a particular process. So first we are going to fetch the instructions, next we are going to decode, and next it is going to basically execute those particular instructions. So this is the introduction of how a typical processor flow is going to run. Yes. So that's all about this particular session. If you like this video, please like, share, and subscribe to my YouTube channel all about VLSI. Thank you for watching this video.